Hey, Algebra 2, and welcome to your first lesson of the year, lesson 1.1. We're going to be looking at key features of functions. Look at our essential question. We're going to figure out how do graphs and equations reveal information about a relationship between two quantities, and that's what we're really getting into. If we graph something with an x and a y-axis, most of the time we're looking at how some sort of variable x is affecting our variable y, right? We input some x and it outputs some y. So let's look at how that really works. Let's get into first just a little exploration. We're going to talk about this diver real quick. So we got a diver going through an ocean search and rescue training. We're looking at the relationship between her depth and the time in seconds since starting her dive. All right, so what can we determine about the dive from the coordinates of the point 5 and -8? So we're talking about this spot right here. Well, we can determine that it had a maximum depth of 8 feet. Or, yeah. And that's kind of the lowest that that person is diving as well. We can also see that that's the point where the person went from descending or going down into the water to where they started to ascend and go towards the surface. What's the average speed of the diver in the water? And how can we tell that from the graph? Well, if we look at it, right, from 1 second to 2 seconds, right, it looks like this person traveled down about a foot, right? And then from 2 seconds, from 1 to 2 seconds, I should say, they went down another foot, right? So it looks like they're descending at about 1 foot per second. And which point on the graph shows the starting location? Well, it's going to be this one right here, right? It looks like the diver started from 2 feet above the water. And this, what else do we call this? We call this our y-intercept, right? So a little jog in your memory from Algebra 1. And while we're talking about stuff from Algebra 1, let's go ahead and review the concept of domain and range. So in order to talk a little bit more about domain and range, in order to really solve this particular question, let's look and define loosely what domain and range are. So domain, in layman's terms, right, is all of your possible x values, and your range is your possible y values. All right, so with that said, let's go ahead and look at the graph of x squared minus 3. You'll notice, that we have this more here. There is a calculator here. If you guys have your TI Inspire or TI-84 calculators, you got some handheld graphic calculator, go ahead and use that. That's fine. If you don't, we can get out our Desmos calculator. Let's go ahead and graph x squared minus 3. There it is. All right, so if we look at all the possible x values this can have, right? If we were to look way out here towards negative infinity, right? there's no values. X just keeps going on forever and ever and ever, right? We're looking at X values for domain. Also, as we go out in this direction, our X values just go on and on forever and ever and ever, all the way to infinity. Well, let's check out what happens with our Y values. As we head this way, our Y values continue to increase, right? Or rather, I should say, my bad, right? As X increases, right, Y is decreasing all the way till it gets to this point, and then it stops, and it starts increasing, and then it goes on to infinity, our Y values. But they stop right here, right? So we would say that for our domain, and I'm going to go ahead and use interval notation for this. Our domain is from negative infinity to positive infinity, right? Those are our X values. They just keep going on forever and ever. But if we look at our Y values and our range, it looks like the lowest value that Y can have, right? The very bottom of that thing is at negative 3. Sorry about that. That's going to go from negative 3 all the way to positive infinity. And we'll leave that as a parenthesis in our bracket because we can't really include infinity. It's not an obtainable quantity. We can't ever actually get there. So there we go. Domain and range of this thing. Done. All right, what do we got next? All right, let's look at this in context. Looking at domain and range. We got an air tanker that flies over forest fires. It drops water at a constant rate until its tank is empty. What is the domain and range of the function that represents the volume of the water the air tanker can drop in X seconds? So the first thing I'd like to know is how long does it take to dump all the water, right? And the way that we can find that is by dividing 8,000 by 400, right? And that's going to tell me how many seconds it takes for the thing to be empty. So I looked at 8,000 divided by 400, and it turns out that that is 20. So what that means is it takes 20 seconds for this thing to have 0 gallons of water in the tanker. All right. What do you think the domain and range of the function are? Well, let's go ahead and look at, I'm going to just draw a sketch graph of this thing. All right, so sketch a quick graph of this thing, right? So here it is, already done and ready for you. It looks like our X value is decreasing. As our X values, I apologize, as our X values increase, the Y values are decreasing. Sorry, I'm multitasking here. All right, so what are all of our possible X values, right? Well, X is never less than 0, right? So then we could say that our domain is going to go from 0 to what? Well, it's empty after, I believe it is 20 seconds. I don't know why there's a 200. After 20 seconds. So our domain is from 0 to 20. I should have a bracket there because we definitely are including the number 20. And how about so that was our X values. We're looking at this, right? Everything that X can be. Let's go ahead and look at everything that Y can be. That's our range. And it's weird because we're going to kind of put it backwards because we need we need to put our lower value first. So right here we have the point 20, 0, right? So that's our lowest y value that we encounter. So we're going from 0 to, how high does y go? Well, y goes as high as 8,000 here at the 0, 8,000 point. So there we go. We have our range, right? Y never goes below 0, never goes above 8,000. And x never goes below 0 and never goes above 20. All right. All right, let's find the domain and range of each of these functions, okay? So in order to do this, I'm going to look at the graphs of these, all right? That's going to be my main approach. So I'm going to go to Desmos, and we're going to graph the absolute value of x minus 4. And in Desmos, you have to tell it ABS means absolute value of x minus 4. There it is, graphed there. All right. So let's talk about this thing. What are all of my possible x values? Is there anything that x can't be? As we go this way, this is probably just going to keep going up and up and up, right? It's never going to stop. So x is going to go all the way out to infinity that direction, and then, negative infinity in that direction, and it'll go to positive infinity in this direction. And it doesn't stop anywhere, right? So we would say then that our domain, and I'm just going to go ahead and use interval notation for these, and not the set filter notation. So it goes from negative infinity to positive infinity. Let's look at the range. What are our possible y values? Or what can y not be? Well, definitely, at this point, right, y is never going to go below that point. So, what are the coordinates at this point? They are 4, 0, right? And that's my y coordinate. So y is never going to go below 0, but it does touch 0, right? Does it ever stop as it increases? Are there y values that aren't included for very large y values? No. So this thing is all going all the way up to infinity, but we don't include it. All right. All right, let's look at this one. Let's find the domain and range of this last one right here. We're going to do 6x minus 2x squared. Let's get the calculator out again. 6x minus 2x squared. Here we go. Oops, I don't know what happened there. Ah, that's perfect. All right, there we go. All right, so again, imagine this piece, right? As we go in this direction, it just keeps getting more and more negative, right? As we go out this way, this is also just going to keep getting more and more negative. And it doesn't look like it stops, right? So as far as our domain goes, it looks like we have the same situation, right? Our domain is going to go from negative infinity to positive. Our range, that's where it looks like there is something interesting going on, right? This is not going any higher than this point. And let's figure out where that point is. How are we going to do it? It appears to be around what, 1, 2, 3, 4.5 and 2.5. So this looks like about 2.5. I'm just making an estimate here. We could find the vertex. That's going to kind of get us away from what we're doing. So it looks like as we go down, right, these values, our y values go all the way to negative infinity, but stop at 4.5. And we're going to include that point. Sorry about that. All right. Oh, good grief. All right. Let's get this out of the way. Okay. Let's go on to the next one. All right, so let's now take a moment to talk about x and y intercepts. So we got a little example. It gives us some context. Kind of nice. So we got this car. It's got a full tank of gas when it leaves. We got the number of gallons of gas, right? So it outputs gallons of gas left in the tank to number of miles the car has traveled, x. So what that equation does, what that y equals 16 minus 0.05x does, is you input some number of miles in for x, right? You substitute that number in for x, work out your arithmetic there, and it outputs the number of gas, or the gallons of gas that should be left for x miles. You got a graph of that as well, right? Of course, it makes sense, right? It's going to steadily decline until there is 0 gas left, right? Gas is our y-axis, and distance is our x-axis. What do the x and y intercepts say about this? So it's really what the question is asking. So let's look at these two things. Let's look at the y-intercept, right? And of course, that's where it crosses the y-axis, right there. Well, what does it represent at the situation? Well, I believe that represents a full tank of gas, right? Number one, you got a full tank of gas. Number two, it represents the beginning of the trip, right? We have not started driving yet, or these people, whatever it is. I'm not driving with them. Not that I wouldn't, but, you know, I just don't know them very well. Anyhow, what about here? What about our x-intercept? What does that tell us? That tells us we're out of gas, right? And we have also traveled the maximum amount of time that we can in this car. So in context, our y-intercept a lot of times is a starting point. And our x-intercept is going to be where our values that we've chosen for our y-axis are going to change from being positive to negative. And we'll go into that a little more as we go on. All right, we'll move on from that question. Get rid of our little arrows we got here. All right, so now that we've talked about what an x and a y intercept might mean in context for a situation, how are we going to find x and y intercepts? Particularly for something with an absolute value in it. All right, so let's have a look at this one. Two things that we need to talk about before we start, right? What are we going to do to find x and y intercepts? Well, isn't it true that if we're looking at a graph here, right, every single point that's on your y-axis, right, has an x-coordinate of what? Has an x-coordinate of 0, right? So this might be 0, 1, and this is, maybe it's a 0, 3. I don't know. My units aren't set up very well. The point is that every x-coordinate is 0. So what would I do if I wanted to find my y-intercept? Well, for my y-intercept, we're going to let x equal 0. Okay, so that's what we're going to do first for our y-intercept. So let's do that. Y is going to be equal to, I'm going to substitute 0 in for that absolute value. So what have we got? The absolute value of 0 is 0. So y is negative 3. So that is our y-intercept. Well, for the same reason, isn't it true that everywhere on the x-axis, every single point on the x-axis has a y-coordinate of 0. So if I want to find out what my x-intercept is, I'm going to go ahead and let y equal 0. So let's go ahead and do that. So this was finding our y-intercept. Let's go ahead and find our x-intercept. I'm going to rewrite the problem here. Absolute value of x minus 3. So let's go ahead and let y equal 0 now. So I'm going to substitute 0 in for y. Absolute value x minus 3. Maybe I can scoot this down and get a little space. That's okay. Let's go ahead and subtract 3 from both sides. Or add 3 to both sides, right? So if I add 3 here and I add 3 here, I'm looking at 3 is equal to the absolute value of x. Now, does that mean x equals 3? Well, yeah, for sure. But it also means something else. It also means that x is negative 3, right? Because isn't it true that the absolute value of 3 is 3 and the absolute value of negative 3 is 3, right? So that means that each one of those values satisfies our equation. So because of that, we're going to say that x is going to be equal to 3 and that x is going to be equal to negative 3. In other words, this particular equation has got two x-intercepts, all right? This is a relationship. It's also a function. I was tripped up on what to call it. It's all of those things. Y equals y equals absolute value x minus 3 has 2 x-intercepts, 1 y-intercept. All right, so let's move on to another example. Here we go. Ooh. So what are we noticing about this? First of all, looks like it's a little different, right? Before we had y equals, now we've got this g of x, right? G of x, that gx, we say that g of x, right? You're familiar with function notation that usually says f of x, same kind of thing, right? G of x in this case, same thing as y. We're going to treat it exactly the same. Now, what did we do? Well, earlier we talked about how to find the x-intercept. So I'm going to go ahead and just mark down what I'm looking at. So for our x-intercept, what did I do? I let y equal 0. In this case, we're going to let g of x equal 0. So 4 minus x squared. All right, so I'm going to subtract 4 from both sides, and I wind up with negative 4 is equal to negative x squared. And I just don't like all those negative signs, so what I'm going to go ahead and do is divide both sides by negative 1. Negative 4 divided by negative 1 is positive 4. Negative x squared divided by negative 1, because a negative divided by a negative is a positive, gives me x squared. All right, well, I can solve this by taking the square root of both sides. There it is. The square root of 4. Oh, and I got to keep in mind, right, when I'm taking a square root, in order to solve a problem? I got to consider both positive and negative values, and I'll explain that here in a moment. Let's get to the solution, and then we can flesh that out. Hey, the square root of x squared is x. So I get that x is equal to plus or minus 2, right? And it makes sense. If you go ahead and plug positive 2 into the original equation, you will get a true statement. Also, if you plug, if you were to plug positive 2 in here for x squared, you'll see that you get 0, right? Additionally, if you plug negative 2 in there, you'll also see that you wind up getting 0. So we have another situation where we have two solutions, which means that there are two x-intercepts there. Awesome. How about the y-intercept? Well, we said for a y-intercept, we were going to let x equals 0. So I'm just rewriting the problem there. When x is 0, in other words, g is 0, we get that y is 4, right? I put g of 0 there because, right, if we're going to substitute 0 in for 1x, we're going to have to do it for both, right? So our y-intercept then is at 4. Hey, let's go ahead and write these down as coordinates as well. I didn't do that on the last problem. That's nice. Our y-intercept, it turns out, is going to be the point 0, 4, right? Those are coordinates. Over here, we've got y-intercepts at the coordinates 2, 0, and negative 2, 0. All right. All right, so let's go ahead and erase this stuff. Move on to the next concept here. And that is that we're going to identify positive or negative intervals. So for what intervals is the function f of x equals x squared minus 9 positive? And for what intervals is the function negative? Okay, well, there are a couple of different approaches to this. I'm gonna show you both. Well, let's see. I'm gonna click on my More tab right here, and let's go ahead and graph this thing with our Desmos calculator. Since it's right there. If you've got your handheld graphing calculator somewhere nearby, use that. It's fine. I've got this one, so I can say I can put in here. Come on. Oh, good grief. Here we go. X is my little caret squared. Usually we're looking at x squared minus 9. There it is. Well, let's go ahead and zoom out on this thing and let's see. Well, it looks like it has a y-intercept at what, negative 9? Does it ever go down at that point? So what I'm noticing with this is that as this function moves to more positive values, as it goes from negative to more positive values, the function is decreasing, right? As my x values increase, my y values are decreasing all the way until we get to this point at negative 10. And then after that, as my x values increase, right, as my x values increase, my y values are increasing, right? So it's just simply that, right? As we're moving from left to right, we're looking to see, does the function go down or does it go up? Right? That's kind of the simple way to say that. And I've noticed that from negative infinity to 0, right, as far as x values go, this function is decreasing. It's going down. But when we get to negative 10, we see that the values begin increasing, right? As my x values increase, the y values increase. So what we're going to say then, if we go back over here, is that, get rid of all that, it's increasing. On the interval, or we can just give the interval an interval notation, right? We're going to include negative infinity. And remember, these are x values all the way up to 0. Yes. All right, so next thing we're going to do is identify positive and negative intervals, especially for this function, or particularly for this function f of x equals x squared minus 9. What does it mean for an interval to be positive or an interval to be negative? Well, it just means that our y values are either positive or negative, right? So for any part of the function that is above the x-axis, that function is positive. Below, negative. Actually, let's go ahead and look at x squared minus 9 using our Desmos calculator that comes with our book. And let's go ahead and graph this. Let's see what I'm talking about here. We're going to graph x. Well, that's a graph of y equals x. X squared minus 9. Here we go. That's what it looks like. I'm going to go ahead and zoom out so we can see what's going on with it. So what we're noticing is this function goes from being positive to negative right here, right? We're not talking about whether it's going down or whether it's going up. We essentially have a cutoff here at our x-axis. And anything below that is negative, anything above it is positive. So you'll see that this function, right, if we're going all the way from negative infinity to here, right, it's above the x-axis, so it's positive, or above the x-axis from negative infinity to, good grief, I believe that's negative 3. This is the point. It looks like that's the point, negative 3, 0. Not that that's important for what we're doing, just to show you that we're stopping at negative 3. All right, and then it looks like from here, right, if we're looking from here to here, it's negative, right? Everything is underneath the x-axis. So we would say then that it is negative over the interval from negative 3 to positive 3. And then it's going to be positive from the interval from positive 3 all the way up to positive infinity, right? Because it just keeps going and going and going in that direction. Okay. So what's the next thing that we want to know about? Well, let's look at what intervals this is positive. So over what intervals is 2x plus 10 positive? Now, I can plug in a bunch of different numbers for x and see if I get a negative number or a positive number. But you can do a lot of like guess and check kind of stuff there. If you look at the graph, you'll know exactly what's going on. And let me show you what I'm talking about. Let's graph this thing 2x plus 10 real quick. There it is. So it looks like this point right here has the coordinates -5, 0, right? So anything from this way on is going to be negative. Anything from this point on, I should say from that point right there. I guess I should have drawn it in a better spot. Anything from this point on, like this, right, is going to be negative. And from this point on, the graph is above the x-axis, so everything there is positive. So what we would say then is we would say that this is negative from the interval from negative infinity all the way up to -5, right? That's where it's underneath the x-axis. And then over here, we're going to say that this interval is positive from -5 all the way up to positive infinity. So we're going to do that. That was the answer to this question here, this try it number 3 that we were looking at. So, and we talked about which one was negative and where it is also positive. So the next thing for us to look at is identifying the intervals where a function is increasing or decreasing. So let's go ahead and do the same thing that we were doing before. Let's go ahead and look at the graph of the function g of x equals -2 minus the absolute value of x. Again, I'm going to go ahead and get out my calculator. So that's not where I find it. Here it is. I'll get out the graph calculator. Let's go ahead and graph this thing. 2 minus, and then I'll just say abs for absolute value of x. And that's what that thing is going to look like. Let me just, hopefully it'll keep it up there for me. Nope. Good grief. 2 minus. Right. Okay. So when we're talking about where a function is increasing or where it's decreasing, we're saying that the line is essentially going up, right? If it's going up, it's increasing. Whoops, I can spell. It is increasing. If it's going down, it is decreasing, right? So it's different from finding where it's positive or negative because we're not necessarily caring whether it's above or below the x-axis. What we're looking for is, does it have, is it going up, right? In this case, does it have a positive slope or does it have a negative slope? So that's what we're looking for. So it looks like right here, right, is where it changes from increasing to decreasing. Right, so this is where it's changing. So that's going to be one of our boundaries on our interval. So we're going to say that the function f of x equals 2 minus absolute value x is increasing over the interval from -infinity to 0, right? Because we're talking about x values, and that it's decreasing over the interval from 0 to positive infinity, just like that. Oh, I missed it. There it is. All right. So let's check out another one. How about x squared minus 4x? What values of x is this increasing or decreasing? All right, well, let's, again, I want to get out a graphing calculator. Again, if you have your handheld calculator, it's probably nicer to use that because you can have something separate from your computer to look at. You'll notice that this graph kind of gets in my way a little bit.
Battery, please charge.
All right, get this thing back out. X squared minus 4x. Let's go ahead and graph that real quick. X. All right, there it is. All right, so we'll identify that this point is where it changes from
battery, please charge.
Decreasing to increasing. So once we've identified that point, we can see that our function all the way up to that point is decreasing here up to that point, and then you can see it's constantly increasing, right? It's always going up. So what's that interval? So the interval for which it's decreasing, then it's going all the way from negative infinity, because it just keeps going on forever and ever and ever in that direction, right? So from negative infinity all the way up to x equals 2, right? Because we're looking at the actual x coordinate of that, right? And then we've noticed that it's increasing from the interval from 2 to infinity. Good stuff. Okay, moving right on to the next thing. Example 5. Where we're going to talk about average rate of change over an interval. So we're going to introduce a formula to you that looks a whole lot like the slope formula. And that formula looks like this. We're going to have f of b minus f of a over b minus a. All right, and that is how you find it. So we'll get an example in there so that you'll understand a little better where this comes from. Let's go ahead and look at it. All right, so if we're looking at average rates of change, for these guys, well, what do you think? Let's look. I think I'm missing a little information. So what does an average rate of change tell you? It tells you how quickly the function is decreasing or increasing. Short, long story short there. Let's actually, I really would like to apply this. Here we go. This is what I'm looking for. Let's get it done. All right. Let's go ahead and try one. So we're going to apply this formula. It says that f of b minus f of a over b minus a is our average rate of change. Okay? That's how we're going to get that. Okay. Well, we've got a couple intervals to do, actually 3. We've got a bunch of work ahead of us. We're going to have to first identify some things. So the first thing we're going to do is we're going to look at the interval from -2 to 0. Whoops. I'm going to put that bracket in there because we're not including that particular point. Or we are including it. Apologize. And we have a function, y equals absolute value of x plus 2. All right. So when we're doing this, this is A, this is B. So f of A, or yeah, so f of A would be, right, I just plug in A instead of there. So in this case, that's going to look like f of -2 is absolute value -2 plus 2, which turns out to be 4, right? Because the absolute value of -2 is 4. All right. All right, so f of -2, right? So we're first, that's f of a, right? Now we need to know what f of b is. So this quantity right here, this 4, that's what we're going to plug in there for f of a, all right? How about f of b? So b is 0. So f of b, what that means is everywhere I see an x, I'm going to plug in a 0, or f of 0, I should say, right? Okay, so it turns out then that f of 0 is equal to 2. All right, so that's what I'm going to be plugging in there. So let's go ahead and look at what we've got. So I'm going to go ahead and just write all that stuff over here. F of b, we said, is 4. F of a, we said, is 2. Over here, right, we indicated that a is -2 and that b is 0. So on the bottom we have b, or 0, minus a, which was -2, so minus -2. 4 minus 2 is 2. -0 minus -2 is +2, or 1. What does this say about the function? It says that on the interval from -2 to 0, it's increasing, right? Because my average rate of change is positive, right? If we had -2, right, then we could say that the average rate of change is -2, and that means that the function is decreasing over that interval. So I'm going to go ahead and skip over doing 0, 3, and -2, 3, and just get you that example as it stands. Let's go ahead and get rid of this. All right. All right, so let's bring it back full circle and let's answer our essential question. How do graphs and equations reveal information about our relationship between two quantities? Well, we can say where that relationship is positive. We can say where it's negative. What else did we learn? We learned about x and y intercepts. Those can tell us where different quantities are at 0. What else did we learn? We learned where a function is increasing or decreasing, right? As we can find out as x increases, is y decreasing or increasing? What's going on? So those are some of the things that we can learn. The term 0 of a function, you've probably heard this, or you should have heard this in Algebra 1. A 0 is the same thing as an x-intercept, right? X-intercept. All right, so Alonso said that this function is positive on the interval from -1 to 5, and negative on the interval from -5 to -1, right? Now, he's kind of right, but at the same time, he's also wrong, right? And what's wrong? The problem is this 5 and this -5, right? As we're going out this way, this goes out to positive infinity. And as we're going out this way, we're going out to negative infinity, right? So what Lonzel should have said was that it goes from -1 to infinity is where it's increasing, or it's positive. I'm sorry, I misread the question entirely. I'm talking about where it's positive and where it's negative. And my bad. Let me back up. That was correct if I was talking about increasing and decreasing. But unfortunately, I am not answering the right question. I got to talk about where it's positive and negative. So it's positive and negative from here. It's positive from here on. This whole part is negative, right? So from -4 to 2, it's negative. Good grief. and it's positive from negative infinity to negative 4, and positive from, right, starting from here, 2, all the way to positive infinity. Sorry about the mix-up. I just love, for some reason, talking about where functions are increasing and decreasing much more than I love talking about when they're positive or negative. Just remember, when a function is positive, it is above the x-axis. When a function is negative, the graph is below the x-axis. All right, guys. So now what I'd like you to do is go ahead and go through this Do You Know How? Click through these answers in your online book, or through these questions in your online book, and give them a shot. This is going to be some practice. I've given you guys examples. You guys have everything in your toolbox to do these. Give them a shot, look at them, and as well, your assignment is going to be number 13, 18 through 27, all 29 and 32 from the practice. Remember, you have to do all of these problems. The Algebra 2 team will be picking certain problems from sections 1.1, 1.2, and 1.3 to be on your homework check. So make sure you've got these all done. Make sure they're correct. Come to us with questions, and we'll answer them for you. And you should do perfectly on the next homework check. Thank you so much for watching. I'm so glad you're with us. Have a fantastic day. Bye, Algebra 2.